Welcome to the deep dive. Today, we're looking at, well, maybe the most fascinating visitor our solar system has ever had, Object 3I Telis.
Yeah, it's a really big deal. That 3i tells you straight away it's interstellar.
Right. Only the third one we've confirmed, after Oumuamua and Borisov, a visitor from way out there.
Exactly. And this one is different. Faster, maybe older, chemically weird.
That's our mission today, isn't it? To unpack all that. The incredible speed, this potentially shocking age, and the chemistry that's got scientists talking. It's got some surprises.
It really does. And it all started pretty recently. It was spotted July 1st, 2025.
By the ATLA survey down in Chile.
That's the one. And when they found it, it was already 4.5 AU out. So quite far, but already heading inwards.
And they figured out quickly it wasn't one of ours.
Yeah, the path was the giveaway. It wasn't sticking around.
Okay, let's dig into that path, the physics of it. What makes it definitively interstellar? How do we know, for sure?
It comes down to the trajectory. It's unbound.
Mm.
You see, things in our solar system, they orbit the sun in ellipses, basically loops. They're caught by its gravity.
Right.
But 3i Aeolus, its path is hyperbolic. It's moving way too fast with the sun to grab it and pull it into an orbit. It's just swinging by.
How fast are we talking here? Because I heard it's fast.
Oh, it's record-breaking fast. It's speed way out, relative to the sun, what we call the hyperbolic excess velocity.
Yeah.
A whopping 58 kilometers per second.
58? Wow, how does that compare?
Well, Oumuamua was about 26 kilometers. Borisov was around 32 kilometers.
So this is nearly double Borisov.
Pretty much. It's seriously hauling. A new speed record for these kinds of visitors.
And that speed, that affects the shape of its path, right?
Yeah.
The sources mention this really high eccentricity, 6.14.
Exactly. That number basically tells you how stretched out the orbit is. An eccentricity of 0 is a perfect circle. Less than 1 is an ellipse.
And 6.14 is?
Way beyond 1. That means it's a hyperbola. It's so stretched, the sun's gravity barely bends its path. It looks almost like a straight line zooming through.
Just a quick flyby then.
A very quick flyby.
Yeah.
Its closest point to the sun, that's perihelion, is set for October 29th, 2025.
Okay.
It'll be about 1.36 AU away then. So that's between the orbits of Earth and Mars.
And that's when it's moving fastest.
Yep, it'll hit peak speed then, around 68 kilometers per second.
Okay, important point though. No danger to Earth.
Absolutely zero threat. It won't come any closer than about 1.8 AU to us. Plenty of space.
Good. But there's this weird detail about its path, isn't there? Despite coming from interstellar space, having this highly tilted, almost backwards orbit.
Yeah, 175 degrees inclination, so it's retrograde, going against the flow.
Right. Despite all that, it lines up almost perfectly with the plane of our solar system, the ecliptic.
It's described as coincidentally closely aligned, which is kind of an understatement. It's bizarre.
Just cosmic luck.
Seems like it. Imagine traveling light years, maybe millennia, from some other star, only to slice right into the same flat plane where all our planets orbit. It's improbable.
So that incredible speed, that trajectory, does tracing it backwards tell us where it came from, like its galactic address?
Well, we could trace the vector back, yes. It seems to have originated from the direction of Sagittarius.
Near the center of the Milky Way.
Exactly, towards the galactic center, which was actually a bit of a surprise.
Oh, so?
Most models predicted we'd see more of these objects coming from the direction the sun is moving towards, the solar apex, not from the galactic south like this one.
Okay, so an unexpected direction.
Yeah.
And this leads to maybe the most mind-bending part, its age. The sources suggest this thing could be ancient.
Yeah, that's where things get really wild.
Yeah.
Some researchers have linked its trajectory, its velocity components, to what's called the thick disk population of the Milky Way.
The thick disk. What does that mean for its age?
The thick disk is, well, it's an older part of our galaxy. It contains stars that formed much earlier, possibly during the Milky Way's initial formation stages, maybe even through early galaxy mergers.
So old stars.
Very old stars. And if this object originated there, associated with those stars, well, the age estimates they came up with are between 7.6 and maybe even 14 billion years old.
Wait, 14 billion? Our solar system is only 4.6 billion years old.
I know. It's incredible. This comet, this piece of ice and rock, could potentially be older than the sun itself by billions of years.
Think about that. It could have been wandering the galaxy long before our planets even started to form.
It's humbling, really. It probably formed in a disk around some long-dead star, way out past the point where carbon dioxide freezes the CO2 frost line.
And then got kicked out.
Most likely. Maybe by a giant planet forming, or a close encounter with another star. Then it just drifted through interstellar space for potentially billions of years until it stumbled into our system.
And that long journey preserves something unique, didn't it? Its chemistry, which you said was weird.
Definitely weird. First off, yes, it's an active comet. We can see the nucleus, the solid bit.
How big is that?
Estimates vary quite a bit, maybe 0.3 to 5.6 kilometers. Most likely under 1 kilometer, though. It's hard to pin down precisely.
Okay, small nucleus. And it has a coma.
Yes, a fuzzy cloud of gas and dust around it. Kind of reddish, actually. Similar to 2I Borisov and some asteroids we call D-types. So it looks like a comet.
But the chemistry isn't typical.
Not at all.
Yeah.
This was the big aha moment, mainly thanks to the James Webb Space Telescope.
On Spherex too, right? They both looked at it.
Right, the big infrared space telescopes. They found it's extraordinarily rich in carbon dioxide, CO2.
How rich are we talking?
The measurement for the CO2 to water ratio is about 8.0 plus or minus 1.0. That is incredibly high. One of the highest ever seen in any comet, especially this far out from the sun.
Wow. So what does that mean? Is the whole comet just packed with CO2 ice?
That's one possibility. Maybe it formed in a part of its original solar system that just had a ton of CO2 ice available.
Or the sources mention another idea.
Or maybe it has a really thick outer layer, like an insulating crust, that formed over its billions of years traveling through space. This crust could be stopping water ice from turning into gas easily.
Making the CO2 seem much more dominant when it heats up.
Exactly. We don't know for sure which it is, but either way, it points to a very different formation history or a very, very long journey.
Fascinating. Was CO2 the only unusual thing? I thought there were other detections too.
There were. The VLT, the Very Large Telescope, spotted cyanide gas, CN. That's fairly common in comets. But it also detected atomic nickel vapor.
Nickel, like the metal in
Yeah.
gas form.
Yeah, it's definitely unusual to see, but the amounts were actually similar to what we sometimes detect in comets from our own solar system.
Yeah.
So strange, but maybe not uniquely interstellar strange.
Okay. But there was something missing too, right?
Yes, and this is just as important.
Yeah.
The VLT didn't see atomic oxygen or simple carbon chains like C2 dicarbon or C3 tricarbon.
Meaning it's low on those specific carbon molecules.
Extremely low.
Yeah.
Highly depleted is the term. So you have this weird combination. Super rich in CO2, but super poor in these carbon chain molecules.
That sounds unique.
It's one of those carbon chain depleted comets we know of. Put it all together, the high CO2, the low carbon chains, and its chemistry is unlike almost anything from our own Oort cloud or Kuiper belt. It really screams formed somewhere else under different conditions.
Okay, so we have this incredibly fast, potentially ancient object with bizarre chemistry. Oh, and of course, it's hard to get a good look at it, right? Let's talk about the observation challenges.
Yeah, that's the frustrating part. First, it's faint. At its brightest, it's only around magnitude 12.
So definitely not visible with the naked eye.
No way. You need a decent-sized telescope, even at its best. But the real kicker is the timing.
What about the timing?
Its closest approach to the sun, perihelion on October 29th, happens when we basically can't see it from Earth.
Why not? Oh, is it behind the sun? Solar conjunction.
Yeah. Exactly. Around October 21st, it gets too close to the sun in our sky. The glare just wipes it out. So right when it should be most active and interesting near the sun.
We lose sight of it. Ugh, that's painful for astronomers.
It really is. We know it was active before that, though.
Yeah, you mentioned the coma. Did it develop other features, like a tail?
It did. Initially, observations showed this plume, like a jet of dust, pointing towards the sun, probably from the side being heated.
Makes sense.
But later, it developed a proper anti-solar tail, pointing away from the sun, pushed by the solar wind and radiation pressure.
How big did that get?
By mid-September 2025, reports said it was around 100,000 kilometers long. So definitely showing classic cometary behavior.
With it moving so fast, I guess sending a probe was never really an option, like intercepting it.
Not realistically, no.
Yeah.
Especially since it was discovered relatively late, already heading in fast. To launch something from Earth after discovery to catch up with it,
You'd need a massive rocket.
you need an insane amount of velocity change, what we call delta V, over 24 kilometers per second. It's just way beyond our current capabilities for a rapid intercept mission like that.
So no close-up pictures anytime soon. We're stuck with telescopes and maybe other spacecraft already out there.
That's the hope. We have to be opportunistic. There's a chance the orbiters around Mars might see something.
When's that?
3I TLS makes a reasonably close pass by Mars on October 3rd, 2025. About 0.19 AU. So maybe MRO or MAVEN could get a look.
Any other possibilities?
Well, the GIC spacecraft heading out to Jupiter.
The Jupiter Icy Moons Explorer.
Yeah. It's going to try and observe 3I TLS in November 2025 as the comet is heading back out.
That would be great data.
It would, but because of where GA will be and data transmission rates, we probably won't get that data back on Earth until February 2026, so a bit of a wait.
Okay, before we wrap up, we have to touch on it. Anytime something weird and fast comes from interstellar space.
Ah, yes.
Yeah.
Speculation. Is it aliens?
Right. Did that happen with 3A Atlas? There was that paper by Avi Loeb and others, wasn't there?
There was. Early on, they highlighted some of the, let's say, unusual aspects. The trajectory alignment we talked about, some initial estimates of its size being large, the fact that its specific chemical makeup wasn't immediately obvious.
So they floated the non-natural idea.
They raised the question, yes, suggesting maybe we should consider it wasn't a comet.
How did the rest of the scientific community react?
Mostly with disappointment, frankly. The
Very-
overwhelming consensus, very quickly, was that this is a natural object, a comet.
And the follow-up observations cemented that.
Absolutely. As soon as JWST and the VLT got good spectra,
The chemistry sealed it.
exactly. Finding high CO2, water, cyanide, even the nickel. But these are all things we expect, or at least can understand. In comets, even very unusual ones, the classical cometary activity, the outgassing, it quashed the non-natural hypothesis pretty definitively for most researchers. It's just a really, really interesting natural comet.
Sometimes the universe is weirder than fiction, I guess.
Mm.
So that's 3IA less. It came speeding in, set records, showed us some truly bizarre chemistry, maybe gave us a glimpse of something older than the sun, and now it's heading back out into the void.
Yeah, it's on its way out. A fleeting visit, but what a visit. It's given us this incredible snapshot of the kind of materials that might be floating around out there, formed in star systems vastly different from our own.
That CO2 richness especially, a fossil record from a nursery billions of years older than ours.
Precisely.
So here's something to think about. We've now seen 3 interstellar objects up close, sort of. Oumuamua was weirdly shaped and inert. Borisov looked much like one of our own comets. And now ATLS, the super-fast, potentially ancient CO2-loaded one.
3 very different objects.
Right. So if something maybe billions of years older than our sun, from a completely different part of the galaxy's history, has this drastically different chemistry, rich in CO2, poor in carbon chains, what does that really tell us about how common or varied planet-forming ingredients are across the galaxy?
Yeah, are the building blocks wildly different everywhere? Or are there just many ways to make an icy body?
Does every star system potentially fling out its own unique brand of comet? And what completely new chemistry, what other secrets about the galaxy's composition might the next interstellar visitor bring when it eventually arrives? Makes you wonder what else is out there.